Greetings, Houdini Python students. In this lesson, we will be covering the Who.ObjNode class. A Who.ObjNode is a reference to an instance of an object node in the Houdini scene. And the methods of this class manipulate how an object is displayed and how to manipulate its world space matrices. Now, because an object node is a subclass of the Who.Node class, we can automatically get a Who.ObjNode value when we drag and drop a scene object onto a variable. And let's go and open up our Python shell and create a new variable for our ball here. Say ball equals drag and drop the object. Okay, we now have the ball. Now, if we just type the word ball here, we see it prints out it is indeed a Who.ObjNode. So we get that automatically because it's a subclass of the Who.Node superclass. Now, the first handful of methods control how and if the object is displayed. They all behave basically the same way with either a set or is method. The set method sets the state to a given true or false Boolean, and the is method returns a true or false Boolean query. Let's first start with the set display flag. So I'm going to say ball.setDisplay. Okay, this controls whether the display flag is on or off. So I'm going to say off, and as you see, the thing disappeared. Now, if we do a ball is display flag set, we'll get a false, and we can return that to true. Now, the next method is the is object displayed. Now, this returns whether the object is displayed or not. Ball is object displayed. Okay, now this is just a query node, but this actually takes under consideration both the display flag and the display parameter. And the display parameter is actually found here in the geometry. If you go over to the transform, the material, or the render, and you engage the display parameter, you can actually toggle this off and the thing disappears. And if we do is object displayed, it'll say that it is false, which means it's not displayed at this moment in time. All right, so I like to turn that back onto 1 because this is easily a place for confusion. Now, as a rule of thumb, when displaying objects for ease of visual use, I like to toggle the display flag. However, when the display needs to be keyframed or expression driven, I like to use the display parameter. The next method is the set selectable in viewport, which sets the object selectable flag true or not. Set selectable in viewport, and I'm going to say this to false. And as you can see, the little green flag here turned off. Now, if I try to grab this, it's not going to grab, so it's not going to work. So, and of course, if we do ball.is selectable in viewport, it better give me a false value, and we can turn that around with a true statement in the set command. Okay, ball.set selectable in viewport true. All right, we turned it back on and we can select it. Now, the next one turns the object's X-ray mode on or off, and that is the use X-ray command. Now, my computer is a bit broken right now, and my X-ray shader couldn't compile very properly, but I'll give you an example. Ball.use X-ray. I'm going to set that to true, and it's going to set it into X-ray mode. And in here, in this situation, it just looks kind of sort of like the normals are inverted. And likewise, the is query tests that state. So is using X-ray, and it is true. But I'm going to set this back to false to get it back to where we were before. Now, the next methods deal with the object's transformations, or its translates, its rotates, and scale values. Now, you may need to be pretty familiar with linear algebra, matrix math, and space transformations to understand what all these methods do. However, the basic rule of thumb is this. The world space transformation of an object is the product of the object's parameter transformations, the object's pre-transformations, and the parent's transformations. And the first method is getting that parent information. So the parent and subnet transformation returns the parent and containing subnet transformation matrix. I'm going to create a new variable, parent equals ball.parent and subnet transform. And what this does is return a 4x4 matrix containing the parent and subnet transformations for this particular object, and we assigned it to parent. The pre-transform returns the object's pre-transformation matrix. So pre equals ball.pre-transform. And this also returns a 4x4 matrix for the pre-transformation. Now, you riggers might know a little bit about this. Now, the parm transformation actually returns the parametric or the parameter matrix set by the object's parameter. So if we go to transform, we should see these are the current parameters for this particular box object. I'm going to say parm equals ball.parm transform. Okay, and that's going to give us a 4x4 matrix for that. Now, the next command, the next method, world transform, gives the combinant or the product of the object's parent, its pre-transformation, and its parm transformations. And the method for that is world transform. So world equals world ball dot world transform. Okay, we've got a 4x4 matrix. So I'm going to create a product of the parent, pre, and parm transformations. So I'm going to say product equals parent times pre times parm. And I'm going to test this to see if it equals the world, which it should. So print product equals world. So do they equal each other? And they do, in fact, equal each other, which is a good thing. The next method is the move parm transform into pre-transform. Now, this is actually you riggers might be very familiar with this, but this sets the object's parameter transforms to the identity and adjusts the pre-transform so that the world transform doesn't change. So I'm going to type this ball.move parm transform to the pre-transform. And what the ball is going to change, the ball is not going to move in position, but you see its translates values went to 0. And we can test this by going to the ball objects and middle clicking it, and we see that the pre-transform now contains those values which were once in the translation and is now in the pre-transformation. So you riggers were probably familiar with what to do with this. Now, to wrap things up, we discussed the who.ObjNode. Its methods have two primary functions, and that's to control how the object is displayed, and for those heavy into the math and how to access and manipulate the world space transformations. Now, this later information may seem kind of dry, but for those comfortable with matrices and Python programming, you'll begin to recognize the power these methods can provide. The next lesson, we're going to cover the who.geometry class. I'll see you next lesson.